Hi, Dido. Hi, Sufi. Hi, Amira. Hi, Afif. Hi, everyone. Today, we will going to conduct the gel electrophoresis experiment. A gel electrophoresis is a tool utilized by molecular geneticists to separate and analyze different parts of macromolecules such as DNA, RNA, or proteins based on its size, mass, and charge. This method works because most macromolecules are negatively charged. When they are placed in the gel wells on the negative end of the chamber and an electric field is applied, the molecules will migrate to the positive end through the gel's microscopic holes. The smaller and negative molecules will migrate further to the positive end and vice versa. If the molecules are dyed, we can observe the distinct bands and interpret the results. Okay, let's start now.
Step 1. Making the comb. First, we need to make a comb to create wells in the gel that will eventually hold our samples. When we make the comb, make sure we use a hard stick so it will stable the comb for the electrophoresis process. Next, when we start to tap the stick, we should tap each of the segment of the comb perpendicular to the main stick that acts as the holder. Put as many sellotape so the comb will stay together throughout the process. Make sure the segment have same distance to each other. We should hang down each of the stick to make sure it did not touch the bottom of the container. This allows small amount of gel to be under the stick for the electrophoresis process to occur.
Step 2. Preparing the gel. Firstly, we need to measure about 1 gram of baking soda and 0.5 gram of agar-agar powder. After the measurement, we need to make a 0.2% of sodium bicarbonate buffer by dissolving 1 gram of baking soda in 500 milliliters of water. We will need approximately 100 milliliters per setup, half to make the gel and half to run our samples. Next, we need to make a 1% gel solution by adding 0.5 gram of agar-agar powder to 50 milliliters of sodium bicarbonate buffer. We will need 40 to 50 milliliters of gel solution per setup. To dissolve the agar-agar powder, we need to heat the gel solution in the microwave, stopping every so often to stir it. We need to watch the solution carefully, as it will quickly boil over when hot enough. When we see bubbles, stop the microwave and stir the solution until the agar-agar particles completely dissolve. The solution should be translucent and will solidify at room temperature. And lastly, we need to let the solution to cool down. Once the solution is cool enough to pour, add just enough to the box so that the comb tips are submerged approximately 0.5 centimeters. Thinner gels will yield better separations.
Set 3. Set the electrode in place. First, we need to cut stainless steel wire more than the width of the container. Bend the wire so that it forms a hook for it attached to the container. Second, after the electrode were being prepared, we need to cut the end part of the gel in the container using any tool like knife or ruler. Just a small part on both ends. and remove the cut parts. Then, arrange the electrode into the gel.
Step 4. Preparing samples and set up our power supply. While waiting for the gel to be firm, we will prepare a few different samples by mixing 1 to 2 drops of food coloring with drops of glycerin. We will be using red, blue, green and purple color. After that, we will carefully remove the comb. After that, 20% of sodium bicarbonate that has been prepared earlier will be poured into the area that the gel has been removed. Make sure the solution is at the same level as the gel. Next, we will use needle syringe to inject the color into the gel. Then, we will make a high voltage power supply by connecting 5 9-volt batteries. Clip 2 crocodile clips to the batteries at the positive and negative terminal. Negative terminal must be connected to the start and the positive terminal to the end side.
The blue and red dye don't separate because they are primary colors, but for the green dye, the yellow and blue color are separated, and for the purple dye, the red and blue color are separated. This is because molecules that are smaller in size will travel further than the larger molecules, as smaller molecules can go through the gel's microscopic holes easily. In conclusion, we are able to separate the macromolecules using gel electrophoresis, and based on our result, we can say that the smallest size among these colors is the yellow color, followed by red, then the blue color. As we can see here, we are able to separate each dye because all the molecules have different sizes.